welcome to the deep dive. Today, we're going to tackle some seriously intense CISA module review questions. But before you think, is this just for the tech geniuses out there? No, trust me. Whether you're like getting ready for some big meeting or just like kind of curious about how the software we use every day gets made, this deep dive is going to, I think, give you some really good knowledge.
Yeah. You know, what's really cool about these questions is that they go beyond just the techie stuff.
Yeah.
You know, they really look at the core of the process and the logic, you know, how we actually build and manage these really complicated systems, things that apply to like so many different fields, not just software, right?
Okay, so let's jump right into the first question. And it throws us right into the world of these object-oriented databases, or like ODBs, as the cool kids call them. Yeah. These things are designed for data that is, well, the question gives us a few choices here. What do you think is the best fit? Predictable, consistent in structure, fixed length, or variable?
Well, the real key with these ODBs is their flexibility. You know, they're designed to handle data that doesn't fit neatly into those like rows and columns.
Right.
Like a classic spreadsheet. Think more like a web, you know, like a network of all these interconnected objects. So I'd say the answer is variable.
Okay. So it's not just like storing data points. It's storing like the relationships, the actions, all that.
Exactly. You got it. Imagine an ODB, but it's for, let's say, a social media platform. So you've got these users. They're objects, right? And they have properties like their username, their profile picture, all their posts. But you also have these things called methods. Think of them as actions like add a friend, or you like a post, or share that content. It's all kind of, you know, interconnected and always changing.
Okay, that makes a lot more sense. It's like this dynamic web of information, not just some static table, huh?
Yeah, exactly.
So let's go to question number 2 here, which is kind of sticking with this whole object-oriented thing, right?
Right.
It wants us to explain a program object. Again, we got a few choices. What do you think best defines what this program object is all about?
Well, you know, we just talked about objects, right? They combine both data and actions. So the answer's got to be that it contains methods and data. It's not just like a passive container. It's this active entity that can do all these different operations.
Oh, okay. So an object is like a mini program within itself. It has its own data and then instructions on what to do with that data.
Yeah, you got it. And it's that modularity that makes this whole object-oriented programming thing so incredibly powerful.
Okay.
Because you can build these really complex systems, but you're just combining these self-contained objects.
I'm starting to see why people like this approach. It seems very organized, very efficient. Okay, question number 3 here takes us to the world of 4th-generation languages, or, as they like to abbreviate it, 4GLs.
Right.
They're supposed to make development faster, which sounds amazing, but is it really that simple?
Well, 4GLs can definitely speed things up, especially for like certain types of applications. You know, they use these really cool visual development tools, and they have like this simplified way of writing code, which means you just write less code overall. So the answer here is that the 4GL provides these like screen authoring and report writing utilities that basically automate how you access the database.
So it's kind of like it handles a lot of the boring, tedious stuff.
Yes.
Makes it easier for the developers to focus on the big picture, right?
Yes. But there's always a but, right? 4GLs don't magically solve everything.
Right.
You know, they can automate certain tasks. But that really tricky logic of the application, like those business rules that really determine how the whole thing works,
Yeah.
that still needs like a human to carefully design it.
Right, because you can't just tell the computer, go make me an app that does X.
Right, exactly.
You need to define how it should work, how should it make these decisions, all of that.
Absolutely. That's where like human creativity and problem solving, those skills are still like super essential.
Yeah.
Even with these like advanced tools like 4GLs.
So it's not a magic bullet, but it is a powerful tool in the right hands. This leads perfectly into question number 4, which is all about software testing. Specifically, it asks us about the best way to review the logic in a program script. And it throws out this term, black box test. What's that all about?
Okay, so imagine you're trying to figure out how a really complex machine works, right?
Yeah.
But you can only see what goes in and what comes out. You can't see all those gears turning on the inside. That's kind of what a black box test is.
Oh, okay. So you're essentially testing out if it works, right?
Yeah.
Without getting bogged down in the code itself.
Yeah, precisely. This is so important for making sure the software actually does what it's supposed to do, you know, and that it behaves properly from a user's point of view.
That's a really interesting way to think about it. It's like, okay, if I push this button, does the right thing happen?
Exactly.
Now, let's dive into some database concepts. Questions 5, 6, and 13 kind of get into some, like, heavier stuff here. We've got ACD properties, normalization, and referential integrity. These sound kind of intimidating, I'm not going to lie.
They sound complicated, but they're really all about making sure that your data is accurate and that it's efficient.
Yeah.
They're kind of like the unsung heroes of reliable information systems, I should say.
Okay, let's take these one by one. Question 5 just throws this term out. Atomicity, consistency, isolation, durability, or like ACID for short. It asks which principle includes this idea of writing all or nothing to the database.
Yeah, that would be atomicity, consistency, isolation, durability, ACID as a whole.
Okay.
Imagine you're like transferring money online, right? You wouldn't want money taken out of your account and then like it never reaches the person you're sending it to.
Right.
ACD properties make sure that these transactions are treated as like one whole unit. So either the whole thing succeeds or it fails completely. That way your data is safe.
So it's like a safety net for the data,
Yeah.
making sure everything happens as planned. Or like not at all.
Oh, exactly.
Okay,
Yeah.
that's reassuring. Question 6 is defining database normalization. This sounds very technical. Can you break this down for us?
Absolutely. Normalization is just about organizing data in a really smart way so you don't have any unnecessary repetition and you avoid inconsistencies.
Okay.
Let's say you have a customer database, right? You wouldn't want to store the same customer's address like in multiple places, right?
Right.
Because then if they move, you got to update it everywhere, and that increases the chance of like making errors.
Yeah.
Normalization makes sure that each piece of data is only stored in one place and then it's linked to other data points. So it creates a much more streamlined and reliable system.
So it's like cleaning up your messy closet and organizing everything neatly.
Exactly.
So you can find what you need. Okay, question 13 asks about referential integrity. What is that?
Well, referential integrity, it's all about relationships. It makes sure that the links between these different tables, they're actually valid. Imagine it like a chain of command. Every order should be traceable back to like the proper authority. Similarly, in a database, every time you reference data in one table, it should have a corresponding entry in another table.
Gotcha.
And that prevents these broken links and keeps the data nice and consistent.
It's like a quality control check, huh? Making sure everything's connected properly. I'm starting to see how all these concepts work together to make this like really robust database system. Now, let's shift gears and talk about these expert systems with question 7. This sounds like we're entering like the world of AI a little bit.
Yeah. While the term expert systems might sound all futuristic, they actually depend on rules and these things called heuristics that are defined by, us humans.
Oh, so even the expert systems are learning from us. Not the other way around yet.
For now, yes.
Okay.
They are super powerful tools, though. They can process tons of information and apply these rules to make decisions, but the rules are ultimately set by human experts.
Okay, that makes sense. And it really emphasizes the importance of human knowledge, even in the most advanced technologies.
Well, I think we've covered a lot in this first part of our deep dive. We went through some pretty dense concepts, but you've managed to break them down so even I can understand.
Well, it's all about connecting these technical ideas to things we see in our everyday lives and understanding how they actually impact us.
Exactly. And I'm already starting to see the world of software development and this whole IT management thing in a totally new light.
Welcome back to the deep dive. We're going to keep exploring those CISA review questions, really digging into the core concepts that make information systems successful.
I'm ready for more. These questions are like little puzzles, and I feel like I'm finally starting to get the hang of solving them with your help. Okay, great. Well, let's jump right into questions 8 and 9. These focus on what are called maturity models and post-implementation reviews, which are basically ways of assessing and improving how software is developed and managed.
Okay, so question 8 mentions something called the Software Engineering Institute's Capability Maturity Model, or CMM. What is that?
Imagine a ladder with like all these different rungs, and each rung represents a higher level of maturity in software development practices. That's basically CMM. It helps organizations figure out their strengths and weaknesses and gives them a roadmap for how to get better.
So it's like a benchmark for measuring how well an organization is doing with its software development. It helps them see where they stand and where they need to go, right?
Exactly. It's all about continuous improvement and striving for that, excellence in software development.
That makes sense. And then question 9 brings up post-implementation reviews. These happen after a software project is complete, right?
Yeah, once the software is up and running, it's so important to step back and see how it's actually performing, you know? Is it meeting its goals? Are there any unexpected issues or areas where it could be better? That's what these post-implementation reviews are for.
So it's not enough to just build and launch the software. You also need to make sure it's actually delivering value and doing what it's supposed to do.
Absolutely. Think of it like buying a brand new car, right? You wouldn't just drive it off the lot without taking it for a test drive.
Uh-huh.
Post-implementation reviews are like the test drive for software projects.
Oh, I like that analogy. It makes perfect sense. Now let's move on to question 10, which presents different migration methods. I'm assuming this applies to more than just software.
Oh yeah, for sure. Migration is all about moving from one state to another. It could be moving data from an old system to a new one, moving an application to a different platform, even physically relocating a data center.
Oh, wow. So it's kind of like moving houses then. You have to plan carefully, pack everything up, figure out all the logistics, and make sure everything gets to the new place safe and sound.
Exactly. And just like moving, there are different ways to do it, and some are riskier than others. This question wants to know which method has the lowest risk. That would be parallel migration.
Parallel migration, what does that involve?
Think of it like having a backup plan. You're running the old system and the new system at the same time for a while, comparing the results and making sure everything's working smoothly in the new environment before you switch over completely.
So it's like having a safety net, just in case something goes wrong during the transition. It might be more work up front, but it minimizes the risk of any major disruptions, huh?
Exactly.
Okay, question 11 introduces this term, data mart, which sounds a bit technical. Can you help us understand that?
Sure. Think of a data mart, like a specialized collection of data that's just for a specific department or project. It's like this mini warehouse that only holds the information that's relevant to a particular team's needs, so it's super quick and easy for them to access and analyze.
So it's not like this massive data warehouse that has everything. It's more focused, more tailored to a specific task or team.
Exactly. Data marts are all about making data more accessible and useful for making those important decisions.
That makes sense. It's
That
like having a really well-organized toolbox with all the right tools for the job at hand. This next one, question 12, is about IDEs or integrated development environments. These are like tools that make life easier for developers, right?
Oh, yeah, for sure. IDEs are like the Swiss Army knives of software development. You know, they have this huge set of tools that streamline the coding process. Writing code, editing code, debugging, testing, everything is there.
So they're like one-stop shops for developers, everything they need to build software efficiently.
Exactly. IDEs can help developers write code faster, find errors more easily, and just be way more productive overall.
Okay, question 14 tackles this subtle but important difference between certification and accreditation. I'm not sure I fully get it.
Okay, so think of it this way. Certification is like getting a seal of approval from a technical expert, right?
Yeah.
It means the system has met certain standards and requirements. Accreditation, on the other hand, is more of a management decision. It's like giving the green light to use a system based on its risks and benefits.
So certification focuses on whether it meets the technical requirements, while accreditation is more about whether management feels confident about using the system right.
Exactly. Both are super important for making sure systems are secure, reliable, and actually meet the needs of the organization.
Gotcha. Question 15 introduces the IT Steering Committee. What do they do? What's their role in all this?
The IT Steering Committee is kind of like a bridge between business goals and IT strategy. They make sure that any IT investments are aligned with what the business is trying to achieve and that projects are prioritized correctly.
So they're making sure that IT isn't just off doing its own thing, but actually contributing to the success of the organization as a whole.
Exactly. They're crucial for good communication and collaboration between IT and everyone else in the organization.
Okay, now we get to step into the auditor's shoes for question 16. It asks about the main purpose of an IS auditor when it comes to lifecycle management. What are they looking for throughout a project's life?
IS auditors are like detectives, you know? They're there to make sure everything is on the up and up. They want evidence that projects are well managed, that they meet their objectives, and that they're following all the rules and regulations.
So they're the ones making sure everything's running as it should, following all the rules.
Exactly. They're super important for identifying and reducing risks, improving processes, and protecting the organization's assets.
Okay, let's move on to questions 17 and 18, which dive into planning and design in software development. Question 17 asks about the software development method that includes planning activities right in the first phase of that SDLC model. That's project management, right?
Yep, you got it. Project management methodologies, whether it's the traditional waterfall method or the more agile approaches, they all emphasize how important it is to plan everything out in the beginning stages of a project.
So before you even start writing any code, you got to have a solid plan, right? Outlining the goals, the scope, the timeline, the resources, make sure everyone's on the same page, and the project has a clear roadmap for success.
Precisely. A well-defined plan is like a blueprint for success, guiding the project from start to finish.
Question 18 asks about the design technique used to document the internal logic of functions for, transforming data. Is that where flowcharts come in?
Yeah, flowcharts are like visual representations of the steps in a process, or an algorithm. They're really helpful for documenting the logic of how data is transformed, showing how the data goes in, how it's processed, and what comes out.
So flowcharts are like recipes for transforming data. They clearly lay out the ingredients, the steps, and the final result. It makes it easier for everyone to understand the process and make sure it's implemented right.
Exactly. They're a super valuable tool for communication and clarity in software development.
Okay, let's switch gears now and focus on software testing with questions 19, 20, and 21. Question 19 asks about the type of testing used to test the functionality of, like, commercially compiled software. We talked about black box testing earlier. Is that the right answer here?
You got it. Black box testing is all about focusing on how the software works without actually looking at the internal code. It's the most common approach for testing commercial software because the source code is usually not available for testers to see.
So it's like evaluating a product based on how well it works, without knowing every detail of how it was made. You're just looking at the user experience and whether it does what it's supposed to do.
Precisely. Black box testing ensures that the software meets its functional requirements and works the way users expect it to.
Okay, question 20 asks about regression testing. What's that for?
Regression testing is all about making sure that any changes to the software, like bug fixes or new features, haven't accidentally created new problems.
So it's like double checking to make sure that fixing one thing didn't break something else.
Exactly. It's super important for maintaining the quality and stability of the software over time.
And finally, question 21 describes a method of programming software modules where they manage it in this, like, time box style. That sounds kind of intense.
That's called rapid application development, or RAD for short. It's all about speed and agility, with the team working in these short, focused bursts to deliver functionality quickly.
Oh, so it's like a sprint to the finish line with everyone working super hard to get those features done as fast as possible.
Exactly. RAD can be really effective for projects where the requirements are constantly changing, or in those fast-paced environments where getting the product to market quickly is critical.
Wow, we've covered so much in this second part of our deep dive. It's incredible how all these concepts fit together to make this comprehensive framework for managing the entire life cycle of these information systems.
It's been quite a journey so far, and we're not done yet. Stay tuned for the final part of our deep dive, where we'll explore some more of those interesting questions and uncover even more insights into the world of IT.
Welcome back to the deep dive. We're in the final stretch of our exploration of these CISA review questions, and I gotta say, I'm feeling a lot more confident in my understanding of information systems and how they're managed, thanks to you.
Well, that's fantastic to hear. We've covered a lot of ground, from object-oriented databases to rapid application development, and now it's time to kind of tie it all together and see how it all fits into the big picture.
When we talked about software escrow last time, it left me kind of wondering about the details, like what happens if an organization actually needs to access that escrowed source code? Is it like a straightforward process?
Well, it's not as simple as just asking for the code. Accessing that escrowed source code usually triggers specific conditions that are, outlined in the escrow agreement.
Yeah.
Think of it like a safety deposit box that can only be opened under very specific circumstances, right?
So there are safeguards in place to protect both the vendor's intellectual property, but also the client's interests. It's not like a free-for-all, but a carefully negotiated process.
Exactly. Software escrow has all these legal and technical considerations that need to be, really clearly defined up front. It's like a backup plan for those just-in-case situations, right?
That makes sense. It's good to know there are those mechanisms in place to protect organizations if something happens to the software vendor.
Oh, absolutely. It's all about mitigating risk and ensuring business continuity.
Okay, so our last question, question 25. It's all about the agile methodology. We've talked about how flexible and fast it is, but I'm curious, are there situations where agile might not be the best approach?
Yeah, Agile is a super powerful methodology, but you're right, it's not a one-size-fits-all solution. It really shines in those environments where the requirements are kind of fluid, there's lots of collaboration, and everyone's like open to change. But if you have a project where the requirements are pretty stable and well-defined up front, a more traditional waterfall approach might be a better fit.
So Agile is like a nimble speedboat, zipping through changing waters, while Waterfall is more like a sturdy cargo ship,
Yeah.
best for a pre-planned route.
That's a great analogy. Choosing the right methodology really comes down to understanding the specific needs of the project, the dynamics of the team, and even the culture of the organization.
Well, we've reached the end of our CISA review question deep dive.
Mm.
I feel like I've learned so much and gained a whole new appreciation for just how complex, but also how important it is to manage information systems effectively.
These questions might have seemed kind of overwhelming at first, but we've broken them down, explored the concepts, and even connected them to real-world situations, making it all much clearer.
Exactly. And it's not just about passing an exam, right? It's about equipping ourselves with the knowledge and the tools to navigate this increasingly digital world with confidence and make smart decisions about the technology that shapes our lives.
That's a great point. And here's a final thought for everyone to consider. As technology keeps evolving at this incredible pace, how can we adapt our approaches to software development and IT management to make sure that our projects are not only successful, but they also deliver lasting value?
That's a fantastic question, and definitely something for all of us to keep in mind as we continue to learn and grow in this ever-changing world of tech. To all our listeners out there, keep exploring, stay curious, and never stop diving deep into this fascinating world of IT.